So I'm going to be doing a little video series on thermodynamics, and it's to supplement the unit that I'm doing for my student teaching at Hedrick Middle School. So thermodynamics is the study of heat and temperature and thermal energy and how all of those things kind of affect the world around us and how they're all related. But before I get too into what thermodynamics is, I have to talk about a little thing called kinetic energy. The reason is if you don't know what this is, it's going to be kind of hard to figure out what this is. Right, so we got to start somewhere. I'm going to start with kinetic energy. So what is kinetic energy? Well, simply put, kinetic energy is the energy of motion or movement. Anything that moves has kinetic energy. So it could be something like a rocket. It could be something like a bowling ball, as long as you throw the bowling ball, as long as you put it into motion. It could be a baseball, it could be a bullet, it could be a planet. Anything that moves has kinetic energy. Now, there's two things that affect how much kinetic energy something has. One of those things is mass. So let's take this bowling ball right here. And we're going to take a ping pong ball, right? That's a ping pong ball. I'm going to ask the question, would you rather get hit in the head by the bowling ball or the ping pong ball? No, if you're a sane person who doesn't care for getting head injuries, you're going to say, oh, I'd rather get hit by the ping pong ball. It's lighter. It's not going to hurt as much when you get hit. Now, that's you intuitively knowing that a ping pong ball has less kinetic energy because it has less mass. Right, so if the mass is large, kinetic energy is large too. Alright. So, another thing that affects kinetic energy is speed. How fast something is moving, or slow. Let's go back to our example. Let's say this time we have two different ping pong balls. One of them is being thrown at 10 miles per hour, another one of them is being thrown at 90 miles per hour, and they're both aimed straight at your head. Alright, here's you going, oh my gosh, no! Straight at your head. Now, would you rather get hit by the one going 10 miles per hour or the one going 90 miles per hour? Well, most of us are going to say 10 miles per hour because we know intuitively that that's going to hurt less. It has less kinetic energy. Less kinetic energy. Right, so there's two things. Speed and mass. Both of them affect how much kinetic energy you have. So if things that we can see, like bowling balls and rocket ships and all that kind of stuff, have kinetic energy, what about little things that we can't see? So maybe things like atoms, or things like molecules, which are groups of atoms. Do they have kinetic energy? Well, if they move, then yeah, they do. And it turns out that the really little things we can't see do move. And they move a lot. Alright, so things like molecules and atoms, they vibrate. Right, or they shake. Kind of another way of saying vibrate. They rotate. Or spin. And in some cases, they bounce around. Hitting each other, hitting container walls, and all that stuff. So, even the things that we can't see are in constant motion. So there's a lot of kinetic energy out there. We just can't see it all. Now let's consider a beaker of water, right? H2O. Let me write that down, H2O. And maybe we've got like 200 milliliters of water in here. Now that much water is about 6.62 times 10 to the 24th molecules worth. That's a really big number. I'm going to write it out just for fun. 662 with another 22 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So there's a lot of molecules in a beaker of water. Now we just talked about in this last slide how even the really small things we can't see have kinetic energy. Every single little molecule, right? Those are molecules in the water. They might look like birds or something. They're molecules. Each one of those has kinetic energy. Now, if we took the kinetic energy in one of them, here's kinetic energy here, kinetic energy here, kinetic energy here, and we added them all together, every single molecule, we would get what's called the thermal energy. So thermal energy is the total kinetic energy of every particle. If we add them all up, that's what we would get, is thermal energy. So if we wanted to write down a definition for thermal energy, we could write that it's the sum total of the kinetic energy, I apologize for my horrid handwriting here, of the kinetic energy of every particle in an object. So like with the water example from the last slide, it's made up of all those little particles. Well, the thermal energy contained in that water would be the total kinetic energy of every particle, every molecule in the water. Now, there's another definition for thermal energy. Actually, instead of putting or, I should put and. Thermal energy is the energy of an object that contributes to its temperature. So here we're starting to hear some familiar terms. We all pretty much know what temperature is. We've all used thermometers. What I'm showing here is that these definitions are really kind of one and the same. So that suggests that temperature is very closely related to the movement of the particles in an object. And it's something we'll get into more detail on when we actually define temperature in another slide. But it's something to think about.